Okay, welcome to the last day of the week. It's Thursday. Hopefully everyone is looking forward to the long weekend as well, even though in some ways it's a little less stressful having to go to work. I find that I'm working a lot harder at home, and you probably are too. We don't have access to the same resources, so I know it's tough for everyone. So I'm just going to say do the best that you can with what you have, and excuse me, we sort things out when we all get back to school, right? Whether that's in September or June. Now, some of you have been contacting me about getting your marks, and you can do that. You can just email me if you can't check in on the live stream every day. There's also a Google Meet every day from 10 to 11 if you want to just pop on and ask math questions. We finished up the law of signs yesterday, so I did the last 3 questions with you as a group, and then I also posted an assignment with answers on the blog for more practice. Today we're going to solve cosines. Now, once again, I'm just going to do a quick refresh for everyone, and if this is old news to you, then I apologize. But the quick refresh is for trigonometry. I'm just going to cover this up. What you learned in grade 11, and we reviewed at the beginning, I think we did a little bit of, we use sine theta equals op over hype, cos theta equals adjacent over hype, and tan theta equals op over adjacent. Okay, we use those for right triangles only. So they have to have that little corner, and we did a review of the types of triangles in lesson 1. They have to have that corner in there to indicate that it's a right angle triangle, okay? For all other triangles, we use the law of sines or the law of cosines. And we're going to do the law of cosines today. Hi, Tiana. Nice to see you back. Okay, so for all other triangles, if they don't have a 90-degree corner, we have to use the law of sines or the law of cosines. Now, when do we use which, right? We talked about the law of cosines. So we talked about the law of sines. The law of sines is when we have an angle given and its partner side, right? I have to have one complete partnership, okay? So we use the law of sines when we have one complete partnership. Use when one complete partnership. So I mean an angle and the side opposite, right? For all others, so we use the law of cosines, use when we don't have a complete partnership. Okay, so this happens. It's easier for me to tell you when to use the law of cosines than when it tells you to use the law of sines, because there's lots more circumstances where you're going to use the law of sines, which is why we did it first. There are only 2 types of triangles. there are only two types of triangles where we use law of cosines. Okay, so that makes it kind of easy. I think it's easy to recognize. Okay, so those triangles are, the first type is when we're given a side, okay, a side, the angle between, and then another side. Okay, so you can see this SA, they're called SAS triangles, side angle side, and this is what they look like. So if I have like 35 degrees, notice this triangle up here, our law of sines, we had the partner, right? For cosines, you never get a partner. So you're given like this side, like 64 meters, and then you're going to given this side, 87 meters, okay? So notice the type of triangle. This is not law of sines. This angle doesn't have a partner side. This side, partner angle's missing. This side, partner's angle's missing. And even if we tried the 180 rule, the 180 rule won't work here because I don't know, I have two angles missing, right? So this is what we call a side angle side. All the information is clustered in one corner. It's like a sandwich, right? So this is a law of cosines question. No problem. And then the other type is, I'm just going to have to move my paper up. The other type of triangle that we must use law of cosines for, right? Once again, there are only two circumstances. So you kind of look for these circumstances. So one of them is side angle side, and the other one's really easy to recognize. If we're given a side, and a side, given all three sides, right? Those will be very easy to recognize because they just look like this, right? Could be like 11 centimeters, 15 centimeters, 21 centimeters, right? All the information you're given, so you're just given side, 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 no angles at all to start even setting up the law of sines. So therefore, there's no way we could set up law of sines. It's a law of cosines question, okay? So this is another law of cosines question. Okay, so hopefully I'll post these notes on the blog too, like just sort of extra notes. And I think we'll get more into it, right? I'll just move this out of the way for a sec. Now, you can see, question, I have two sides. So generally speaking, I'm going to be solving for a side. This is a law of cosines question, okay? And I'll just put that we would solve for the missing side, for the third side. Okay, so this is the side we're going to solve for, right? And then the third one, we would be solve for one of the angles. Okay, that's it. So let's take a look at our first page of notes. So here it says, sometimes when we set up a triangle, we don't know an angle in its opposite side. Okay, in such cases, law of sines will not work. And that's what I was just sort of talking to you about a minute ago. We won't have a partnership, right? So we have two versions of the law of sines, okay? This is the first, the law of cosines. This is the first version. This is the second version. It's actually the same law of cosines. It's just manipulated. It's twisted around. But we use this version, use to solve for a missing side. And this version we use to solve for an angle. Okay, so notice they're labeled A, B's, and C's. That's just standard to label the law of cosines with A, B's, and C's without X's, but I'm going to show you how our X becomes an A or how our A becomes an X, I guess, depending on how you think of it. So determine the side length called X. Now I can see, even if I wasn't told that this is a law of sines question, and you might not have known it at the beginning, you can see there's no partnership, right? So I have an angle, this side's missing. I don't have any other angle, so it's definitely law of cosines. And this is where all the information's in a corner, like the angle is sandwiched between two sides, the sandwich triangle. So we're going to use A squared equals B squared plus C squared minus 2 times B times C times cos of A. All right, whatever side you're looking for, okay, this is the A, okay? So that's your X, right? This is your angle A, kind of nicely represented here, angle A. This side, it doesn't matter what you call it, B or C. These two can be interchanged. It doesn't matter at all, but this side is clearly side A. So when I put all the information into the formula, okay, I'm going to say A squared equals B squared plus C squared, right? So I guess we'll say B is 5. That's maybe a better way to put it. C is 7. Okay. Maybe that's too much going on here. I'm just going to erase these for when I scan them in later so it's not so confusing. So again, I could call this side B and C. The B's and C's absolutely don't matter because you're not asked to find angle B, angle C. So it doesn't matter who's who here. The only matter is that you identify that the angle you're looking for, its partner is your unknown, and that's your A, right? That's your important piece here. So 5 squared plus 7 squared minus 2 times 5 times 7 times cos of angle 51 degrees. Okay. And now you can see the only problem with this formula, it's kind of similar to a problem like that we had with the Pythagorean theorem, the A squared plus B squared is C squared. We don't want to solve for A, right? We actually want to solve for the square root. So let's just, there's two ways we could do this, right? Let's see what we get an answer for first, okay? There's a couple ways we could do this. So I'm just going to type into my calculator 5 squared plus 7 squared minus 2 times 5 times 7 times cos of 51 degrees equals, okay? And I get A squared equals 29.947, and I'm going to do this, right? Just like I did when we were doing law of sines, because these are quite complicated formulas. So I have to do quite a few steps with it. I'm calculator because I really want A, right? Remember how to find A? I don't know if you remember this from the Pythagorean. To find A, I have to I want to square root these, right? I have to square root everything. So I'm just going to press in my calculator. All I should have to do is press the square root button. My square root button is X squared button, so I have to press the second row, okay? So for me, all I have to do is square root, and it remembered my answer, and I press equals, okay? And if that's too complicated or your calculator doesn't work nice, you could just write this number out on a piece of paper and then very last square root. So A equals 5.47. Okay. Now our very last thing is, this is kind of nitpicky, but math is like that, right? Math and science are very detail oriented. So very last thing I do is, they told me to solve for x. So I'm going to say x equals 5.47, just to make it nice and clean. Okay. Any questions at all? Okay, no questions I see. So if you have any, you can pipe in or you can ask me over email. Let's try another one. Okay, let's try this next one. I don't know why I started doing everything in red pen, but I'll do it in black now. Determine the length of the side labeled X. So I try to find law of sines, and I look here and I don't have a complete partnership. I don't know this number. I don't know this angle. I don't know this angle. And I recognize right away that this is a side angle side question, right? So that means that this is A. I'm going to call this one B and this one C, right? And this, of course, is my angle A. Now, if it doesn't bug you too much, I could just, because I know this guy's going to turn into X, I could just call it X squared at the beginning, right? I could, instead of saying A squared, I'm going to say let A equal X. Okay, so X squared equals B squared plus C squared minus 2 times B times C times cos of angle A. Okay, and now I'm just going to substitute everything in. X squared equals B squared plus C squared minus 2 times B times C times cos of 29 degrees. Okay. So let's see. Notice these questions usually result in there's a lot of math to do, but thank goodness your calculator takes. And I get this halfway answer, right? 150.5124. Okay, I'm going to leave that in the calculator. So X will equal the square root of this number, 150.5124. And in my calculator, and I think most of your calculators probably work the same, I leave this big number in my calculator and I just square root it and then hit equals. So X should equal 12.27 if I round correctly. And I think that was feet. That little tick means feet. So I'll just wait for anyone to catch up. And ask me questions if you have any, or you type in, or everyone's fairly quiet online. Sorry, just trying to adjust this. Okay, now this is solving for an unknown side, right? But as the instructions indicate at the beginning, law of cosines, we have two types of questions. If we're trying to find a missing side and also a missing angle, right? So now we'll tackle this version. It's the same law. You can see it's all the same pieces, but solving for an angle, all we did was just move all these pieces to the other side, and it changes the formula slightly. Oh, okay, I'll slow down a bit then. I got a message that someone was lost, so I'm not sure if it's just calculator steps. Remember, if you have a backwards calculator, you'll have to type it in 23 squared plus 15 squared minus 2 times 23 times 15 times 29 cos. You'll have to switch those. Okay. I'm not sure if I should go on. I think what I'll do is I will go on, but I'll stay on the line if you have questions, just so that this video is recorded and people will have some notes. Okay, I'm going to flip the page. And now we're going to see this is using finding an angle, right? Yes, squaring is just multiplying by the number itself. So now we're solving for theta, you can see. So this, we have to use the other version of the formula, and the other version is cos of angle A equals B squared plus C squared. See, all the pieces are the same. We're subtracting the A squared. So it's really important you identify what A is. All divided by 2 times B times C. Now, in the past, when you've had a really complicated fraction, we have to use brackets. Or we have to do the two numbers separately. So I think I might do, is my first clue that I have to use law of cosines. Now, it's really important. It never matters who B and C are, but it absolutely matters who A is. Whatever angle you're looking for is called A, and its partner side, right? The side right across from it is little a. Okay? That matters. These guys don't matter at all. Again, it doesn't matter who you call B and C. They're interchangeable, but A is not. Once you have your partners identified, it's pretty easy. I'm just going to substitute, instead of A, B, C's, and capital A's, right? I'm going to substitute what I see in the question here. So I have 6, 7, 9, and theta. So I'm just going to change all my A's, B's, and C's to numbers and thetas. So cos of, well, instead of A, I'm going to call them theta, right? Equals B squared plus C squared minus A squared, all divided by 2 times B times C. So at the beginning, the setup is kind of hard, but this one, the math, I think, is a little bit easier. So you can either use brackets, or let's do it the long way, because then I know that everyone will get right answers in their calculators, because doing it the long way, you have to have brackets in your calculator, and I'm not sure if everyone has those. So I'm just going to figure out what the top is. 6 squared plus 9 squared minus 7 squared equals, I get 68 on the top. And on the bottom, 2 times 6 times 9, I get 108. Okay? Now, just like you did with Amanda in grade 11, if you were in Amanda's class, or I'm just going to go back a page. When we were solving for the angles in with law of sines, right? And you remember we had this sine theta equals this decimal answer, and then we had to do shift sine. Oops. here. Like when we were solving using law of sines, we had sine theta equals a decimal, and then we just shifted sign. That's what we're going to do for cos. Okay, we're going to do the exact same thing. So we're going to get in our calculators, well, maybe I'll use a slightly different way. I got to get rid of this cos, right? Because I just want theta by itself. So if I want theta, I have to get rid of cos. So I'm going to press my second cos button, right? And I have to do shift cos. I'm going to use a bracket, 68 divided by 108. I'm using brackets. If your calculator puts up a bracket for you, that's great. You don't have to insert it, but I do. And I'm going to see, tell me if you get right answers with this one or not. So second cos, just like we did with the sine, right? So I have to go, I don't want the cos button. See the difference? I don't want that one. I want shift cos. So the cos has to have the -1 here. Okay, and I'm going to really strongly encourage you to look for your brackets. Mine are here. So 68 divided by 108. I'm going to close my bracket, and then I just hit equals. And I get an answer of 50.98 degrees. So it's all about using the formulas, right? As long as you can identify what kind of question it is, and you're organized enough to be able to plug the info into the formula, these are pretty straightforward. Okay, I don't see any other questions. Let's try this last one. So again, I can see this is law of cosines because there's no angles given to me at all. It's side, side, side. Okay. So whatever angle you're looking for, that's your A, right? Which is important to identify because then you just decide who little a is, right? I can call this one B, this one C. Okay, so I'm going to set this up again. I'll rewrite the formula. Cos of A equals B squared plus C squared minus A squared over 2 times B times C. Okay, so initially, the hard part is initially just putting all the numbers in the right spot, right? And the biggest thing for this is identifying who A's partner is, angle A's partner. And once you have that locked in, that's the number that gets subtracted, right? And that's a very important thing to make sure you put that in the right place. So cos of theta equals B squared plus C squared minus A squared all over 2 times B times C. So I'm going to get my top number and my bottom number first just to make it a little easier to type in. 8 squared plus 9 squared minus 16 squared equals, so I get cos of theta equals -111, and that's okay. It's okay for, sometimes in cosine we get negatives, that's okay. Divided by 2 times 8 times 9, which is 144. Okay, so we're almost done. I don't want cos of theta, right? I was told to solve for theta. So the very last thing I have to do is get rid of this. So shift cos, shift it out of there. Bracket, -111 divided by 144. Okay, so let's see. Let's see what theta equals this time. So shift cos, bracket, negative, remember where your negative buttons are at the bottom, -111 divided by 144. And that's going to give me a very large angle measure. That's an obtuse angle. 140.43 degrees. And this little note here is just reminding you in the numerator, right, in the top of the part of the fraction, 2 squares are added and the third square is subtracted. The third square, the one that's subtracted, must be the side across from angle A. So you have to make sure the third one is A, right? And that's the one I can identify A because it's directly across from the theta. Okay, I got a question saying I don't know where my negative buttons are. There should be, they're usually at the bottom of a calculator. And the negative button, it's not the subtract button. It usually is at, well, it could be, like lots of them are at the bottom and it says plus minus, right? So if you just press it, it ends up being a negative sign. Oops. So you're look for a plus minus. Quite often they're at the bottom. Sometimes they're at the side here. Okay, so let me know if you found someone was having a problem finding their negative button. Did you find the negative button? Okay, good. All right, I don't see any other questions from anyone. Sorry, I'm moving all this around. I will post all these notes like I always do. I see a few people watching, but only one is asking questions. So I'll stay on the line a little more. So your homework is work on assignment 3. Do assignment 3. So it is just, it's pretty standard and pretty straightforward. It's just a bunch of law signs and cosines. Anywhere there's an x, if there's theta, you're solving for angles. So that also will tell you which formula to use, right? So again, I'll stay online for another minute or so, just to make sure there's no questions. I also posted, there's a new blog post at the beginning of my WordPress blog that links you to an address for a Google Meet. So every school day at 10 o'clock, I'll open up a Google chat room and you can pop in for a minute or an hour or as long as you want, and you can ask me math questions or any other question you have about school. And that's daily, right? Every school day. So sometimes people have questions that they want, or they just want to chit chat a little bit. They might have questions about school. So I had a couple people join this morning. It's during my normal resource period. If I was at school, I would have resource from 10 to 11. So that's what I've done as well. So see, there's no other questions. So I guess I'll sign off in a minute or so. Remember, there's no school tomorrow because it is Good Friday. So I hope everyone can have a little bit of relaxation. Oh, I'm just going to flip back for a sec. Over this long weekend. I'll just flip here. I think I'm going to end this stream now, and I will post these notes in a couple of minutes.